everybody, how's it going? This is Coding Cleverly, and I just wanted to give a few pointers out for the tree traversal algorithms. Here, tree traversal algorithms can be classified broadly into two categories, mainly the one which is depth first search, which is DFS, and the breadth first search, which is BFS. Now, depth first search consists of three variants. One is pre-order traversal, one is in order, and the other is post-order traversal. And when we talk about the other BFS, breadth first search algorithm, it consists of one variant, and that's called the level order traversal. Now, over here I have a piece of code, and this is basically a constructor which is a tree, and what we have here is in a private section and has a tree node. It works the same thing, has a data which is a string it could store. It has a list and a tree node pointer children, so it's going to store its children here. It has a constructor where you could just pass in the stuff. Here is an OSFS tree default constructor, which is root is equal to null. Over here is basically the parameterized order, you would say. Here inside there's a destructor, a dump function, which is going to be displaying the tree node in a line. So this is a code, has some recursion algorithm, we could say, and there's iteration going on throughout this whole program. So, and then we have a display one, which is going to be displaying it in indent2 spaces. So you're going to see all of this out, and display two is going to be displaying it in indent2 spaces. So you're going to see that one out in display 2q, which is a queue, and it's going to be using a queue here, and we're going to be using it, and you're going to see that there's going to be something different here appearing in display 3. We're going to be something different over here in display 3, which is basically here. This is the code over here, so you can see that there's a logic behind that. And then we have display 4. Here we have display 4 as well. So we have the add root function, we have an add child function, we have the parent pointer, and we have an else statement, which is an exception. Here what we did is we added a root, which is D. Remember, it's like a computer file system. It has a programming fundamentals folder directory inside of this root directory, D, and we have an OOP, and then we have in the root directory we have a quiz, which is inside of PF. Interesting, we have project inside of PF, we have DSA inside of root directory, we have marks inside of DSA, we have entry inside the marks, entry UD inside of D directory, and entry UP inside of the project. So when I do FSR, so this is going to basically use dump, and this is unformatted output of a tree. So you're going to see an unformatted output. Here in FSR.display1, we're going to have a formatted output of a tree using stack and then process node before children. So here you see display 1, display 2, display 3, and display 4. And then we have a display 2 So you're going to see that is going to be displaying using a queue, and other ones like what I talked about in order, post order. So all of that is going to be shown here. So you can see over here, this is pre-order traversing. This is display 3 is going to be showing, and display 4 is going to be ordering post-order traversal. So pre-order and post-order, and then we have the in order, which is going to be over here somewhere, and then we have the one which is the regular. Now just run the code, and it will compile, and then we hit the A, and then here you go. This is how it's executed. So look at that. So let's just take a quick overview of what has been displayed. So over here we have, this was basically called using the dump function. So this is just simply just throwing it out onto the console screen. We have D, an entry UD, DSA, marks, entry UM, OOP, PFA, and project, UP, and quiz. Display 1, which is formatted output of a string tree using a stack process. D, which is has entry UD, and we have DSA, marks, and then all of that. So what this is basically, if we compare with this code here, we have D, and then which one was added at the end. So we have a UD, which was belonging to D, was pointed here. And then we had entry UD, so we see if there is anything over here that is assigned to that process. Here we have DSA. So DSA is part of the D, so it's associated. Here we have marks. Now this is basically a child of DSA. So marks is a child of DSA. There you go. And then we have entry UM is a child of marks. So entry UM is a child of marks. Here we have OOP, which is a child of D. So over here, OOP is a child of D. And we have PF, which is a child of D. And then we have project, which is child of PF. Entry UP is a project of project. And then we have quiz, which is a child of PF. So that's how this one was displayed. And then we have over here the second display 2. Over here we have entry UD, we have a DSA, and we had marks. So, and then we have a entry we have an OOP, we have PF, project, entry, just with indents, so it just makes it a little more like prettier fonts, understand it more easily. Over here, after this dump and the display 1 and the display 2, we have this display 3. So display 3 is basically the pre-order processing, and this is the root. So it goes to the left child. Over here we have PF, and then it explores the whole child. So it says it has the children, quiz, and project, and inside of the project it will explore the children of that, and then once it's done, it goes to the next child. So basically D's next child was OOP. It was trying to find anything related to OOP if there was any descendants, but there wasn't. So it went to the next child from left to right. So DSA started. So this is how basically pre-order traversal works. And DSA had a child, so it had Marks, and Marks had another child inside of it. So it was entry After that, there was no longer any more childs, so it just exited out. And we had we have an entry UD, which was another child of the D. So that's how it appeared from left to right. We explored the whole tree. So that's pre-order traversal. When we have post-order traversal with display 4, here we just have other way around. So post-order traversal is something like when you go at the end of the program. Over here we have, we're going to be searching throughout the whole thing. So we're going at the end. So we'll see that quiz is the one that is at the bottom. So then we have entry UP, and then we have the project. So you can see that quiz, and then we have entry UP, and then we have project, and that belongs to the PF and the OOP. Cool. And then we have the entry and the Marks, and then that's the DSA, and then the entry UD, and then D's at the end. So it's like a bit of reverse, but this is called what you would say post order. So then after that, at the end, we have it displayed using a Q. So we have PF, OOP, DSA, entry UD, we have quiz, project, and so like we understand through the indents what we applied using our code. I'm going to be leaving down a link to this code, so you could just check that out. And this is enough for this video, and we will be seeing you guys in the next one. Peace out.